Okay, look at this question based on half-life and background radiations. A sample contains a large number of radioactive nuclei that emits beta particles. The sample is placed near to a radiation detector in a laboratory and the count rate is recorded over a long period of time. Okay, this is the graph that is given to us. Figure 11.2 shows the count rate recorded by the detector during this period. This is the graph that is given. We have already answered other simpler questions. Measure sources of background radiation. Determine the value of for the background radiation count rate in the laboratory. This is what we are supposed to write over here. Now how this we are going to determine this from the graph. Okay. Now initially, as you see over here, okay, the radiation count is decreasing. At a certain point, after a certain point, then this graph is becoming a straight line from this point onwards. Okay, I'll take the last point over here, this point. I will draw a straight line like this, and whatever this value that I get, of course I'll draw the straight line, and this value that I get, that is going to be the background radiation, because we assume once this part of the graph becomes a straight line over here, we assume that the radiation count because of the radioactive substance no longer exists, and this is a straight line, and this straight line is due to background radiations. So you'll draw a straight line over there and you are going to give me the answer for background radiation, which we are going to verify. Just do this on your own. Okay, we have found this from the graph. This is 22 counts per minute. We are going to the second part of the question. Determine the count rate at time t is equal to 0 due to the sample on its own. So this is the part only because of sample, what is the count rate that we are supposed to find. So we'll just go back to the graph. Okay, background radiation already 22 counts per minute is there. We already found that. How much is the original count rate together when we are counting it? How much is the count rate at this point?
49.
Correct. This count rate is 49 counts per minute. Now out of that, 22 is already background radiation. So I'm supposed to subtract it. Whatever this 49 which is there, it is background radiation plus the count rate of radioactive substance. That together is 49. Usme se 22, from that 22 is background. So from this, if I subtract background radiation, it is going to give me count rate due to radioactive substance. So this value is going to be 27 counts per minute. That is going to be the answer for the next part of the question. Okay, so 27 counts per minute is the count rate due to radioactive substance only. See the third part of the question. Estimate the half-life of the radioactive atoms in the sample. So from this graph, we are supposed to find the half-life. Okay. Now, see, in the beginning, how much is the count rate only due to radioactive substance?
27.
27. This is the count rate in the beginning. I'm saying in the beginning due to radioactive substance only. After one half-life has completed, okay, in the beginning it is 27 counts per minute. After half-life, how much should be the count rate?
13.5.
Half of it. This 27 is only because of radioactive substance. After half-life, it should be half of that. That is 13.5 counts per minute. This should be the count rate. 13.5 should be the count rate per minute only for radioactive substance, but in that also background radiation is present. So
Oh,
I'll have to add
yes.
that. Correct? Just listen to the explanation once again. Okay? 22 counts per rate, that is background radiation. Without background radiation, only because of radioactive substance, it is 27 counts per minute. Only because of radioactive substance. After half-life, it is going to become half of this, which is going to be 13.5 counts per minute. But this 13.5 counts per minute is going to be only because of radioactive substance. In that part also, background radiation is present. So in the graph, that part also will be considered. So I'm just going to add these values, and whatever these values that I get from the graph, I'm going to determine the half-life. So I'm just going to add all of this. So 35.5 I will find on the graph, 35.5 counts per minute. I'll get that on the graph, and I'm going to determine the half-life period. So I go back to the graph. This is the graph. See where 35.5 is there. Okay. So we'll just look into the graph for 35.5. From this I have drawn into the graph. This is what I have done. 35.5 is the half count rate, including background radiation. And from that, I have stretched this arrow down. The half-life of the radioactive substance that I have got is 85 days. I have recorded everything. You can go through this video once I upload it. If you have still questions, we'll do more practice of this kind of questions, and we'll continue further.